Let's talk about finding the sum of an arithmetic sequence. Let's find the sum, S sub n, of the first n terms of the following sequence. We're going to use the sequence, we're going to call it a sub n, and our sequence is going to be represented by 2n plus 3. Let's write out these terms a couple different ways. One way we could write this out is to go ahead and start listing each of our terms. For our first term, we want a sub 1, so I could plug a 1 up in here for this n value and get 2 times 1, which is 2, plus 3. So our first term is going to be 5. I could do the same thing for my second term. I'd have a sub 2, or 2 times 2 plus 3, which is going to give me 7. And I can continue this process. So we're looking at finding the sum of this sequence of numbers. 5 plus 7 plus 9, all the way up into our last term, which is going to be 2n plus 3. That's one way we could write this summation. The other way that you might see it written is with this summation notation. So you could express this same sum by using your sigma notation, going from k values starting at 1 all the way up to n, using the formula 2n plus 3. That would be the same sequence of numbers. When we're looking to find the sum, S sub n, for this sequence, we're going to need a couple pieces of information. We're going to need our first term, which in this case is a 5, and we're going to need our nth term, which in this case is 2n plus 3. Once we have those identified, we can go ahead to our formula in order to find the sum. The formula we're going to be working with is S sub n, that's going to represent our sum. We have n divided by 2, and we're going to multiply that by the sum of our first term and our last term. Let's go ahead and plug in the pieces that we know. We have an a sub 1 value for our first term. We also have our nth term, so let's just go ahead and leave this summation in terms of n. We can plug in our a sub 1 value of 5, that's our first term, and we can plug in our nth term, 2n plus 3, and let's go ahead and simplify what we have here in our parentheses. That's going to give me an 8 plus 2n inside my parentheses, and let's go ahead and distribute by the n over 2. Once we distribute, we're going to get 4n plus n squared. And this would be our formula for the sum of this sequence. If you want to write it as n squared plus 4n, you could do that as well.